Hi and welcome back to my channel. My name is Joshua from Tag. In this video, we would continue on the new series we just started, creating data frames in R programming. So if you could take your mind back to the last video I shared on creating data frames in R, the first video in the series, we talked about how we can create a table in R programming using the data.frame function. So quickly, we'll just revisit what we did in the previous video, and then we'll go to what we have for today, which is just for me to show us some basic functions we can use in accessing a data frame. So let's go by creating a data frame that we'll be using for practice, and then that is the variable we want to store the data frame object inside. We call the variable DAT. So we are going to use the data.frame function from the base package, and then let's say month. There is something I want to mount. Yeah, let's say month, and then I don't want to use months because it is already an existing function from the base package. So I'll say month, and then I use the assignment operator we are familiar with, and then I will say month dot abbreviation. So month dot abbreviation is also an existing function. So what it does is it prints out all the months of the year. The abbreviation, it prints it out for us. So that is the first variable we have in a data frame. So the next variable we are adding to it, let's say temperature. Let's just say temperature. For instance, we are playing. Let's break down this code by pressing enter. Then I say temperature, and then I use this assignment operator again, and I'm like, let's sequence, because we have 12 months in the year. So I'm sequencing from 30 to 52, and I want it to increase by 2. So why am I doing this? So when it increases by 2, so when we have 30, 32, 34, before it gets to like 12 increments, we would have gotten to 52. So having done this, then I can break this code again and say we have temperature, we can say humidity, as humidity, and I use this assignment operator again. So I'm going to use another function called sample from the base package. So when you look at what we have here, R programming is very easy. If you look at it, when I was typing sample, we have talked about this phenomenon, the IntelliSense phenomenon in R programming. So it suggests for you functions that goes with what you want to use. So what I'm interested in is the sample. So when you look at this short documentation that we have here, you could see we have sample. The first argument you will put into it is x. So most times the x is like a vector that you want to sample from. The size is the amount of sample size you are interested in taking out of the entire population, which we have as the s. And then here, this concept talks about replacement. Do you want to replace as you take those values out of the entire population, or you don't want to replace it? So when we mean with replacement, we are saying when you select one out of a particular thing, instead of the entire sample size to reduce or the population to reduce that you are selecting from, it won't reduce. You will still have that value added back again, replaced back. But if you don't want it to replace, you only have few values that will be left as you keep taking some samples out of the entire population. And this probability talks about the number of chances you want to give for values you are taking out. Number of chances. So individual probability that you want for those values, you can include it. So in this example, I will just say sample, and then I'll create a vector that houses the entire population, and I'm saying 2 to 50. That is, the entire population comprises of values from 2 ranging to 50, and then I've specified the S argument. Now the size, I'll just want 12 of them. So I'm just going to leave the concept of replacement out of it. So when I don't do anything with it, automatically I am saying replacement is false. That's the default. So then when I run this entire line of code, look at what happened on the global environment. So on the global environment, we have automatically all these values that we have, the variables that we are combining together using the data.frame functions, are created separately under values. And so we have humid as a class of integer, we have month as character, we have temp as numeric. Don't forget, in the previous video I told us how we can change this particular one that is of character to something that would be of vector, because of factor, because these are in each of the year, the months are having unique values and they are 12 in number. So it is until when you change it to factor that you can perform some operations on that particular variable. For instance, you might be interested in taking out information that belongs specifically to the month January. So you can do that. You can index that when the particular variable month is in the class of a factor, as against the way it is right now in the class of a character. So you would see that we have 12 observations of TV variables. I made the distinction between values and data. I told us the data, when you see it in arrow programming, it's a combination of values. And when you see a table, you will see this icon that looks like a play button. So when you have this, there is something I would say before I go to what I want to share with us right today. So when you see that and you want to access like the humid, so we should put the dollar sign. Look at what will happen. You would see we have this long thing, month dot 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 dot. Otherwise, what we're expecting, meanwhile what we're expecting is just to have dollar sign, and we just have humid, month, and temperature. So one of the reasons why this is happening this way is because of the multiple ways we have been using this assignment operator, even again inside a function. So sometimes it is good for us, in this case, if I change this thing to like equal to, look at what will happen. So then I run this, and then I go and I say that dollar sign. So this is exactly the way it should be. You shouldn't have a long dot. It is fine, you can use it, but sometimes it makes the whole analysis messy. So we're interested in a value for humid alone. If I run this, we have this information. Don't forget, we got the humid by sampling values from 2 to 50, and we just need 12 out of this entire population. We need 12 samples, and you could see 22, 39, 23. So it was selected at random without any partiality. So having done this, now we have a function. Now let's talk about what we want to do with some functions that you can use when working with data frame. So one of these functions is the view. Let's start from view. So when you say view, and you could see the argument you just need to include for now is the variable that houses the table, the data frame. So when you run this, you will see it in a tabular form. So it's going to create like a new separate sheet where you can just view everything you have. So for January, the temperature is 30 degrees C, the humidity is 22. For February, March, April, May, June, July, October, till we have December. So this same thing, this view, is what happens each time you bring your cursor to the global environment and you click on this particular thing. And the moment you click it, you will see that underground, this is what is going on. The view function is being invoked as you click on that particular part of the global environment. So the next thing we will learn is we have an understanding by virtue of the information provided on the global environment that the data frame has 12 observations of 3 variables. So how do we see some of these things? We have talked about the function dimension. So this dimension, the argument to takes the data frame and you run it. So it tells you this is for row and this for the column. So another function again that you can use is the number of rows, n rows. So you see n row, and then you can put DAT. So it tells you the number of rows we have is 12, and the other function is n column from the base package, and you put that again, it tells you the number of column is 3. So sometimes you can write your code and you say n row multiplied by n column, and you run it. Oh, definitely this is going to give us error, because n row, you can't multiply a function by a function, it doesn't make sense. So it's going to be n row of that multiplied by n column of that. So if you run this, you're going to have 36. So this tells you like the entire values that we have in the data frame. So mind you, when we do some live coding like this, there is that tendency of we having some of these little errors, like we just encountered not long ago. So that is that about view, dimension, number of rows, number of column. And again, when you use the length function most times is best used on vector, but when you use it on the data frame, it's definitely going to give you a result, but the result is going to be similar to what you would get by using encode, the number of column, and you say DAT. So that's what the length will give you. Unlike if, because now humid is present on the global environment, so it is not hidden by virtue of the way we created our data frame. So if I say length of humid, so it tells me that humid has 12 observations. So most times the length function is best used on a vector object. So having done this, we have learned some of these functions. We also need this very important function, and that is names. So the names is from the base package. What it does is it provides the names for the column that we have in the data set. So if I say that and I run this, so it tells me we have 3 columns, and the name of each of these columns are month, temperature, and humidity. So that is what you can do with these function names. It reveals the names of the particular columns we have in your data set. So sometimes they might just send a data set to you and you don't have an idea about the data set, so you can just use, or you have forgotten the names of the column, you can use these names. It's an inbuilt function from the base package, and it reveals to you the names of the variables we have in that particular data set. So that is one beautiful thing about that. So one thing again that you can do is you can also say conames. Let's see what will happen. So this particular one now, you are changing the column names, you are changing the name. So if I say that, look at what will happen. It also gives you this particular thing. But with this, you can use both of them. You can use both of them to like rewrite or recreate or add a new name to an existing data frame. So having done this, we just talk about structure, of which I shared something on structure in the last video. So this structure, it's very important each time we are going through exploratory data analysis. And the essence is we don't just jump into analyzing. We need to see the structure. We need to see if each of these variables are in their right classes, the best classes we can use them for the particular purpose we want to use them for. So when I say structure, the argument that goes inside is the data frame. So when we run this, it tells us the structure of each of these observations that we have in the data frame. So we see data frame, this is 12 observations of 3 variables. The month is seen as character, meanwhile it is best seen as factor. So we can change the class from the way it is as month and turn it into a factor. So I'm going to do that in this video, or okay, let me do that in the next video. Let me create a simple video for that, so I won't merge everything together. So we can also use summary. So this summary is a very interesting function that we would see as we proceed, especially when we are developing some models. So summary, we use it to reveal information about any kind of model that we have built. So when I say summary and I put the data frame as the only argument and I run it, it provides the summary statistics. You know, the basic summary statistics, the 5-number summary, and it is always good. It always works best with numeric values, because you can't get the summary statistics for something that is categorical in nature. So for the temperature, the minimum value is 30, the first quartile is 35.5, the median is 41, the mean is 41, and then we have the third quartile to be this, and we have this to be this. So with this, it gives you a clear understanding of the distribution, a clear understanding on the distribution of temperature and the distribution of humidity. So at this point, I would want to say a big thank you. I would want to say a big thank you for, sparing your time to learn with me, and I believe you've been blessed. So for those that are joining for the first time, I would implore us to subscribe to the channel, and don't be selfish. Don't enjoy this alone. You can share with your colleague. The goal is that every young people have access to this knowledge, and they can apply it in their respective field of studies. So thank you very much once again for your time. God bless you. Do have a great day. Bye.